We are from Group 6 and today we are talking about the Chapter 4 heat and the subtopic 4.3 specific latent heat. Latent heat. As we know that all the elements in this earth can exist in three states, that is solid, liquid and gas. The difference in the arrangement and movement of molecules among the three states of matter shows that there are stronger molecular bonds in solid than in liquid and gas. As gas molecules are moved freely at random, the bond between gas molecules is the weakest among the three states. So you can see the figure here. The figure shows the changes in phase of matter. During the changes in the phase of matter, such as melting or boiling, the temperature will still remain constant, even though the heat is being supplied continually. Heat that is absorbed during melting and boiling but without any change in temperature is known as latent heat. So you can see that the figure below, when the gas is condensation into liquid state and the liquid state is freezing into the solid state, the latent heat is released during this process. But when the solid is melted to the liquid and the liquid is evaporated to the gas, the latent heat is absorbed during this process. Specific latent heat. The quantity of heat needed to change the state of matter of an object depends on the mass of the object and its material. Specific latent heat L of a substance is the quantity of heat Q that is absorbed or released during a change of phase of 1 kg of the substance without any change in its temperature. So the below is the formula to calculate the specific latent heat. L is equal to Q over M. So the Q here is represent the heat energy that gained or lost, and the unit used for it is joule, J. And M here is the mass, and the unit for it is kilogram kg. And the L is specific latent heat, and the unit is J per kg. Specific latent heat of fusion of a substance is the quantity of heat Q that is absorbed during melting or the quantity of heat released during freezing of 1 kg of the substance without any change in temperature. And the specific latent heat of vaporization. LV of a substance is the quantity of heat Q that is absorbed during boiling or the quantity of heat released during condensation of 1 kg of the substance without any change in temperature. So we know that the specific latent heat will divide into two types. First is the specific latent heat of fusion and the specific latent heat of vaporization. Okay, here is some info we need to know. Based on the kinetic theory of matter, the higher the average kinetic energy of a molecule, the higher the temperature of the object. Latent heat absorbed during melting and boiling does not increase the average kinetic energy of the molecule. Therefore, the melting and boiling occur at constant temperature.
Heating curve process pure solid is heated until melting point. Heat is absorbed, temperature increase and kinetic energy of molecule increases. Process our as liquid is heated until boiling point. Heat is absorbed, temperature increases and kinetic energy of molecule increases. Process till gas is heated. Heat is absorbed, temperature increases and kinetic energy of molecule increases. Process melting solid to liquid. Process Q solid starts to melt. Process P Q out. Solid is melting. Process R. The whole solid has melted. Latent heat is absorbed to weaken the bonds between molecules. Molecules are relieved from their fixed position and move throughout the liquid. Kinetic energy of molecules does not increase. Constant temperature. Process boiling liquid to gas. Process as liquid starts to boil. Process ST. Liquid is boiling. Process T. The whole liquid has boiled. Latent heat is observed to break the bond between molecules. Molecules are separate far from one another. Kinetic energy of molecules does not increase. Constant temperature. Process PQ. Gas cooled to boiling point. Heat is released. Temperature decreases and kinetic energy of molecule decreases. Process RS. Liquid cools to freezing point. Heat is released. Temperature decreases. Kinetic energy of molecules decreases. Process TU. Solids cool. Heat is released. Temperature decreases and kinetic energy of molecule decreases. Condensation. Gas to liquid. Q. Gas start to condense. Q. Our gas is condensing. R. The whole of the gas has condensed. Later heat is released and molecular bonds is formed. Molecules move throughout the liquids. Kinetic energy of molecules does not decrease. Constant temperature. Freezing. Liquids to solid. Process S. Liquid starts to freeze. As the liquid is freezing, T the whole liquid has frozen. Later heat is released so that bonds between molecules is strengthened. Molecules vibrate around a fixed position. Kinetic energy of molecules does not decrease. Constant temperature. A phase change of matter that involves specific latent heat, melting, cooling drinks, and foods with ice cube. Evaporation cooling body on hot day. Boiling cooling as liquid nitrogen boils. Condensation process of steaming food. Of specific latent heat in daily life. Cooling system in refrigerator. A refrigerator uses the cooling effect from evaporation. During circulation of the cooling agent, heat is absorbed from inside the refrigerator and released outside. First, compressors compress cooling agents that is gas to increase pressure and its temperature. In the condensers, cooling agent gas release latent heat during condensation. The cooling agent liquids flows through expansion wave. In the evaporator, cooling agent liquids evaporates and absorb latent heat from inside the refrigerator. Cooling agent that is gas flows out from the evaporator to the compressor. Example 1. The specific latent heat of fusion of ice is 336,000 J kg power -1. What is the quantity of heat required to meet 2.5 kg of ice at 0 Celsius? Solution is use the formula mass multiply latent heat. 2.5 multiplies 336,000 is equal to 84,000 J. Example 2. 480 W is immersion heater used to melt ice in a container. In 130 seconds, the reading of the electronic balance decreases by 0.172 kg. What is the mass of the ice that has melted during the heating period? Make assumption. Ice is melted by heat from the immersion heaters only. All water from the melting ice flows out the container. Relate the change in readings of the electronic balance to the mass of ice which has melted. Mass of ice melted decrease in the reading of electronic balance equals to 0.172 kg. Calculate the specific latent heat of fusion of ice. Solution. Make assumption. All heat supplied by the immersion heaters is absorbed by the melting point. No transfer of heat from the surrounding into the apparatus. M equal to 0.172 kg. P equal to 480 W. T is equal to 120 seconds. Pt equals to mass multiply latent heat. 480 multiplied 120 equals to 0.172 multiplied latent heat. Latent heat equals to 57600 over 0.172 equals to 3.35 multiply 7 power 5 jkg power negative 1.